Hello students, welcome to Educate. In the last class, we have almost finished the chapter, but finishing the chapter will telling the finishing of chapter will be just like doing the formalities. So we I shall also discuss about few other topics about which we have not discussed, of which some questions are here is beneficial for not only the students who is preparing for NEET examination, main examination, or the CUET examination. That means the competitive examination based on class 12. But the students who is preparing for UPSC and PCS also, and particularly for the PCS examination, that is very important. And UPSC also, that is important. And in addition to that, that means of the number of questions, there is a number of competitive examination based on the graduation level, in which the few topics, that means here particularly the uses of carboxylic acid, that will be highly beneficial because questions asked in those competitive examination from these portions. So the other topics which we have discussed, about that questions don't ask frequently. Okay, so firstly let's see about these questions about which we have not discussed. So let's see here. First question here, draw the structure and then after you will compare, and you could compare this one very easily. So first one structure is okay, don't confuse here. CO2 written, that means here there is two oxygen. This CO2 is different from the CO2 molecule. That CO2 molecule is independent. But here CO2 is not. It is the part of a chain. That means two oxygen here. So actually structure is this. And second one, how to compare their acidic strength? In the first case, here methyl group is here, and a methyl group donate this oxygen attack the electron, here negative charge on the oxygen, here positive charge. Now the oxygen will have to donate the lone pair of electron to this side, so positive charge will appear. Here this methyl group will supply the electron, but meager, not so much. In this case molecule, that means 2-fluoroethanoic acid. In case of ethanoic acid, that was the phenomena involving, and in the case of 2-fluoroethanoic acid, what is happening here? Fluorine is attracting the electron towards itself from the methyl part due to their high electronegativity. Fluorine is the most electronegative element, you know already. So fluorine will attract the electron towards itself. So same phenomena here, oxygen will attract the electron, will acquire negative charge. This carbon will acquire positive charge. Same here, the lone pair of electron on the oxygen will come here for the double bond formation. So there will be positive charge here. Now compare in first case and second case. In the second case, this methyl group is not capable of donating their sigma electron towards this carbon atom. Instead of this donating electron, it will attract the electron from this carbon. So here stress on this OH bond will be more. Here stress on this OH bond is less. So that's why among this compound and this compound, that means among ethanoic acid and the 2-fluoroethanoic acid, the 2-fluoroethanoic acid is more acidic. It is more acidic. Okay, or it is a stronger acid, or it is, you can say it is a stronger acid. So among ethanoic acid and 2-fluoroethanoic acid, the 2-fluoroethanoic acid is a stronger acid. Now in this case, second case, during the comparison of these organic molecules, when you will draw the structure and then after will think, then there will be only bigger than and hardly there will be bigger chance of doing the mistakes, and there will be the probability of doing the mistakes only due to your lack of concentration. So if there will be no lack of concentration and you will draw the structure and then after think over the phenomena affecting them, then you most probably you will not do mistake. Now next question. This molecule. So let's compare here. To this methyl group here, fluorine is attached, which is the most electronegative element, and here the chlorine is bonded, which is not as much electronegative than that of fluorine. So this fluorine will cause more stress on this OH bond compared to that of this OH bond. This fluorine will cause more stress on this bond as compared to this chlorine will cause the stress on this OH bond. So obviously this molecule will be more acidic, or it will be, this molecule will be a stronger acid. Now third one. Now let's see in this compound. Structure drawn. Then fluorine is bonded to the third carbon, 1, 2, 3, 4, fourth carbon atom. And here fluorine is bonded to the third carbon atom. So obviously fluorine, which is causing the stress on OH bond, that is closer to the acylic carbon atom. So that's why this will be more acidic, or it will be a stronger acid. So among this one and this one will be a stronger acid. Now fourth question, let's see. Now I have fluorine, 3 fluorine is here. So obviously it will tend to withdraw the electron from benzene. So there will be more stress on OH bond. Here methyl group, it will donate the electron to the benzene. Here this CF3, tetrafluoromethyl group will withdraw the electron from here, from the benzene. But this methyl group will supply the electron. So here less stress on OH bond. Here more stress on OH bond. So this more stress on OH bond. So more acidic. Now think, when it will ask about the stability of molecule, then what will be your answer? You may comment in the box, and by yourself also you may think. If any help you want, then consult to the YouTube channel Educate. So this one here. So that's why among this molecule and this molecule, this molecule will be a stronger acid. So this molecule is a stronger acid. Okay guys, I hope you felt easy here, and not only that, I hope that you are also enjoying of the chemistry, and now you realize that the chemistry is very easy, it's not a tough subject. Now let's see next question. Then after is uses of carboxylic acid. That is here important, and for the 12th board examination, yes, important, but more important is for the competitive examination, like and particularly the NEET and CUET of the 12th level, and of the questions, and in the questions which frequently asks in the UPSC and the PCS examination also. Let's see. Methonic acid use, very easy, you know methonic acid, rubber, textile, and the dyeing, leather and electroplating. This one. Ethanoic acid, you know that is used as vinegar in food industry. In the chow mein, which you add for the sour taste, that is actually the vinegar. Because in the few restaurants, might be, you have seen that the red chili is dipped in a liquid and the taste is sour. What? That is not water, that is vinegar actually. And in the food dishes also vinegar uses, particularly in the cooking of the fast food, might be you know. So ethanoic acid as a vinegar in food industry. Hexane dioic acid, nylon 66, about that, it is made nylon in nylon 66. How the nylon 66 forms, about that I shall tell you when I shall teach the polymer. But even though, no, let's see right now also. Hexane 16 dioic acid, how nylon is actually, what is actually is nylon. So there is a same 6 carbon chain here. There will be amine. Hexane 1,2-diamine will react with hexane 1,2-dioic acid. How the nylon 66 forms, the hexane 1,16-diamine react with hexane 1,6-dioic acid. Like that, there will be another molecule of hexane 1,2 that will same hexane 1,6-diamine will be this side, and hexane 1,6-dioic acid. A number of places there will be. What will happen? One hydrogen will combine with this OH for H2O. So valency of this nitrogen atom will become destabilized, and that of this acylic carbon atom also become destabilized. So this nitrogen will bond to the air. In the same way as there is, in the same way of this side, amine of this side, here one hydrogen will get involved in the reaction. So this nitrogen will get bonded to the other hexane 1,6-dioic acid molecule. Here also this OH will bond to the NH2 part. That means this OH will bond to the hydrogen of the hexane 1,2-diamine molecule. So this carbon atom, this will get involved with the chain. Here this acylic carbon atom involved in the chain. This nitrogen will also involve in the chain, and this nitrogen. So structure will be NH here. Here 6 carbon here this side, and here also, and here is 4 carbon this side and C double bond, and then after nitrogen here again, and that will continue. So what happened between this nitrogen and this nitrogen? How much carbon is here? 6 carbon. Here is NH. The structure will be what? NH here and CH2 whole 6. Then after here is NH again, NH, and then after C double bond O, and this CH2 whole 4 and C double bond O, and again NH. So what happened here? Between this nitrogen and this nitrogen, there is 6 carbon atom. Same way, between this nitrogen and this nitrogen, 6 carbon, number of carbon is 6. But in this, between these two nitrogen, there is no any acylic carbon. But between these two nitrogen, there is acylic carbon also. So that's why between here, these two is nature is different of the chain, nature is different. And between this chain, between this segment, not telling chain, in this segment, the nature of the CH2, this chain is different. And in this segment, the nature of this carbon part is different. So that's why it is called nylon 6,6. Okay. So hexane 1,6 di. So in the examination, question will not ask how the reactions is here, but in the examination, question will ask in the formation of nylon 6,6, which compound is used, or the nylon 6,6 is the product of the condensation reaction. Nylon 6,6 is the product of the condensation reaction between which two molecules? So option here, one will be hexane 1,6 diuic acid and hexane 1,6 diamine. Okay. Next point, let's see here. What is perfumery industry? So esters of here benzoic acid, that is used in perfumery industry, that is here. Sodium benzoate, very frequently asked question it is. So as a food preservative, which compounds are used? So sodium benzoate, that acts as food preservative. Okay, sodium benzoate structure, I hope everyone know. So that is used in food preservative. Okay, manufacture of higher fatty acids. How that is? What is actually soaps and detergents about that? So I shall tell the structure of soap and detergent will be similar. So I shall not tell in so much detail. Actually, soap is the sodium salt of higher fatty acid, and in some cases also that, okay, keep on that only mind. So sodium, that is the soap is sodium salt of higher fatty acid. Okay. Okay, in detergent also that will be of sulfate ion. Now let's see about this question. Watch out about cyanidin we have discussed, acetyl, ketyl we have discussed, semicarbazone, what is that? Watch out, semicarbazone react with carbazide in aldol condensation, that means aldehyde or ketone containing alpha hydrogen atom. Hemiacetal, during acetal formation, the aldehyde reacts with monohydric alcohol and there will be a formation of hemiacetal, and then after there is formation of acetal. Oxime, you know already, aldoxime there be, and that was reacting with the aldehyde or the ketone. So there was formation of oxime. Ketyl, you know already, that is the dihydric alcohol. The dihydric alcohol reacts with ketone and there will be formation of ketyl. Imine formation, you know already, that ammonia react with aldehyde or ketone, and finally there will be the double bond formation between carbon and nitrogen. Okay, guys, these questions I have already taught you in detail. So you could solve these questions very easy. I am Also, but you don't feel any difficulty to do solving these questions. That's why I am providing you the hint. If anyone feeling difficulties to solve these questions, then watch out the videos again. Now let's see. 2,4-DP derivative, you already know. 2,4-diphenyl, 2,4-DNP derivative, 6 base already studied. Now about the IPAC system of nomenclature, few compounds I shall discuss here. These questions you can do. These questions I am solving. Okay. I am expanding this structure, but you can solve these questions without expanding the structure also. So let's see here. This is the structure here. Now you will have to firstly select that longest carbon chain which includes the functional group. So this is the chain here in the longest carbon chain, no tension here. Then after you will have to do, because here chlorine and here is a ketone. Ketone is senior than chlorine. So that's why you will have to give lower position to the ketonic group. That means this carbon atom to this carbon you will have to give lower position. So if you will do the numbering from this side, 1, 2, 3, 4, then it will C double bond O, acylic carbon will acquire 4th position. And when you do the numbering from left to right, the acylic carbon will acquire 3rd position. So that's why do the numbering from left to right. At 6th chlorine there is at 6th position there is chlorine, and at 4th position there is ethyl. C comes first, then E. So that's why it will be hexane 3 on Y orbital, because ketonic group is at 3rd position, and E will replace by on. That's why. This question is also easy, but okay, maybe few students feel difficulty about 3rd question. Here, simply here 1, because this carbon we will have to include in the main chain. It is 1st, 2nd, 3rd, 4th. So its name will be, at 2nd position there is double bond, so that's why 2E and L. Because CHO here is at 1st position, so directly enol. About this, in this compound here, this oxygen is doubly bonded here to this carbon. This oxygen is doubly bonded to this carbon. So it will be 1st position, 2nd, this side, or so from any side. If 2nd position, then here it is 4th position, and from here 2nd position, then 4th position. So from any side you do the numbering, either from left to right or from right to left. The IPAC name will be same. So any side. E will retain here because there is more than one ketonic group. That's why E will retain, and that is at 2nd position and at 4th position. So that's why 2,4-dione. You do by yourself. Okay, this compound. Okay, very easy it is also. Okay, I am expanding, so maybe few students will feel difficulty. This is the structure. This is the structure. 3-methyl group is bonded to this carbon, and that carbon is included in the main chain. So that's why this is the structure. So the IPAC name 1, 2, 3, 4. At here, 2-methyl group is at 3rd position. So very simple. Why here E has been replaced by oic acid? Only one CH3OH group is there, that's why E has been replaced. Do by yourself. If you will not able to do, then only I shall solve that. Draw the structure, you can do very well. Okay, draw the structure of the following derivatives. Very easy, you can draw. 2,4-dinitrophenyl hydrogen zone or benzaldehyde of benzaldehyde. That's you structure. Draw you that. Oh, okay. Of these questions, I am writing. You do by yourself these questions. Very easy it is. Very easily you can do. Right now, I have discussed also. Its name will be cyclopentane carbonaldehyde. E will retain. Okay, we are not using al. Carbonaldehyde, the suffix and carbonaldehyde we are using. That's why E will retain. Now let's open chain is of only one carbon. So cycle here its impact name will be diphenyl methanol. Do the reaction very easily. You can do that. About this one, reactions due to the reactions involving ammonia and their derivative. In that one, we have discussed in detail. So very easily you can do that question. Now, this question. One question I am solving, then after you do solve by yourself. Cannot you do? Actually, here H3O plus when we write that actually the H plus and OH minus involved in the reaction, but here acid will act as a catalyst. So here MgBr will combine with OH. So what will form? Hydrogen here. IPAC name diphenyl methanol. Its IPAC name is, here I am writing its IPAC name. Okay. Yeah, in this question, but now consider about the 8.7. This question is it remaining question. Tolerance reagent, what is that you don't you already know. Cyclohexane carbonaldehyde when react with tolerance reagent. That reactions very easy you know. Semi-carbazide when react with that. Okay, very easy. Zinc ammonium and hydrochloric acid. Watch out. That we consider about that. The reactions, which was the name reaction. Then after here, this one. So methanol, you will have to consider which compound will give aldol condensation reaction and which compound will give Kenichiro reaction. About that, you will have to consider draw the structure and will have to watch that among this compound, in which compound there is alpha hydrogen atom and in which compound there is no alpha hydrogen atom. The compound which give alpha hydrogen, that will undergo aldol condensation reaction, and the aldehyde which don't contain alpha hydrogen, that will undergo in Kenichiro reaction. As for example, I am telling 1, 2, 3. Here methanol, structure like that, and that will no alpha hydrogen, so that will give. So this compound will undergo Kenichiro reaction. Watch out the reactions I have already taught. What is that? Second questions I am doing. No, this structure these questions I am doing. Okay. Now watch out here. This is carbon of functional group. This is alpha carbon. So there is alpha hydrogen. So alpha hydrogen. So it will undergo in aldol condensation reaction. Now let's see the product. So same type of molecule will be there. Now what happened? Hydrogen of this one will go to combine to this oxygen, or this hydrogen combine to this oxygen. Anyone can happen. The product will be same. So structure of the compound will be what?